In this video, I'll be solving question number 48 of HC Verma. Question number 48. Alright, so this says that the swimmer has to cross a 500-meter river. Now, it is given to us that the velocity of swimmer with respect to water is 3 kilometers per hour, and the swimmer heads at an angle theta with the direction of flow. So let's take this to be the direction of flow, and that's how the swimmer goes. So this is velocity of swimmer, but the angle is given to us with respect to the flow of river. So therefore this must be the velocity of swimmer with respect to river. Let this angle is theta. Now we can resolve these two velocities, that is velocity of swimmer with respect to river equals, in vector notation, velocity of swimmer with respect to ground in vector notation minus velocity of river. That's also in the vector notation. So velocity of swimmer with respect to river can be given as, because it goes with 3 km per hour, so it is 3 cosine theta I cap plus 3 sine theta j cap, and on the right hand side we have velocity of swimmer with respect to ground minus 5 I cap, because the river flows horizontally. This implies that velocity of swimmer with respect to ground becomes 3 cos theta plus 5 I cap plus 3 sine theta j cap. Now once we have this, what we can do is we can find out the time it takes to cross the river, because it is going with 3 sine theta in the y-axis. So we will say that the time required to cross the river is 0.5 kilometers, because the speed are in kilometer per hour, so that's why we are doing this, divided by 3 sine of theta. So this is our first equation. Now the same way we can say that the distance covered, let's call it S horizontally, will be equal to the horizontal component of the velocity with respect to ground, which was 3 cos theta plus 5 into the time we just found. So this thing becomes 3 cos theta plus 5 times 0.5 divided by sine theta. Now we need to find the minimum distance that the swimmer will have to cover after crossing the river. So what we can say is we can minimize this ds over d theta equal to 0, because theta we don't know at what angle it goes. Theta is the variable here, we need to find that. At what angle theta will the S be minimum? So let's do this. If we differentiate it, we get 0.5 3 cos theta plus 5 minus cos theta over sine square theta minus 3 sine theta over sine theta. That's just plain differentiation, nothing else. This implies, because this thing is equal to 0, this implies that minus 3 cos square theta minus 5 cos theta divided by sine square theta minus 3 equals 0. If we take the LCM, we will finally get cosine theta equals minus 3 over 5. So if cosine theta is minus 3 over 5, that means sine theta must be 4 over 5. That's because angle theta is obtuse, so it is in the second quadrant. Because sine theta is positive in the second quadrant as well, that's why we took the positive 4 over 5 and not the negative one. We found this using the relation sine theta equals square root of 1 minus cosine square theta. Now once we have sine theta and we have cosine theta, we can plug this in our formula for S, which was this. So let's plug in over here. We get S equals 3 cosine theta is negative 3 over 5 plus 5 into 0.5 over 4 over 5. We've just plugged in all the values. So this becomes negative 9 plus 25 over 5 times 5 times 0.5 over 4. After solving this, we get the distance S as 2 over 3 kilometers. I hope you understand this problem. So see you next time. Thanks for watching.